Hello friends, today we are going to see the topic of multiple input and multiple output antennas. We have seen so many types of antennas and this is one such which has the advantage of using RF frequency ranges. Here the multiple input and multiple output antennas have been of four different types. One is with single input, single output, single input and multiple output. This one, and multiple input and single output, multiple input, multiple output, and these are the four different types where you can come across. So we'll see one by one what is it. First of all, seeing about multiple input and multiple output. One first configuration is single input and single output. Here you will have only one transmitter and only one receiver. This is the typical diagrammatic representation. You can see one transmitter with one receiver. So the thing you're using this type of system is it is being simple, and nowadays you can't use this kind of system. It's used in the previous cases like single input and single output, but nowadays it's not applicable and it's not much recommended, but it's used in previous cases. The second category is single input and multiple output. You can see the diagram that this is the diagram where you have only one transmitter with two receivers, and it has an advantage that it is easy to implement, but still it is limited by the size, cost and battery drainage. When you are implementing it for the first time with multiple receivers, you need a lot of size, capacity, cost, and you have to consider your battery also. So it has a quite disadvantage towards the three factors like size, cost and battery. But still it adopts two forms of methodology. One is switched diversity SIMO and another one is maximum ratio combining SIMO. So switched diversity SIMO is when you are using receivers twice, multiple receivers. The thing is you can switch to the receiver which has the strongest signal. Okay, you no need to depend on only one receiver. If suppose the other receiver has a strongest signal, you can switch easily without any loss in data. So the second thing is maximum ratio combining SIMO. So here you no need of switching. Instead you can take the combination of two receivers. You can sum the signals between two receivers in order to contribute the maximum overall signal. So it is also recommended these two features. The space switch to diversity and maximum ratio combining SIMO. These two comes under multiple receivers with single transmitter. So third category is multiple transmitter with single receiver. In other words, multiple input with single output. So here this is the diagram. You can see with multiple transmitter with single receivers. So receiver is able to receive the optimum signal. The main reason is to receive the optimum signal because you have the transmitter in multiple cases. The resultant transmission is of optimum. There is no loss of data. Efficient transmission, one important point. Here the processing is moved from receiver to transmitter in case of redundancy or code checking. Okay, so there is a positive impact on size, cost and battery. When you are using multiple receiver, these three are problems. The size, cost and battery. When you are using multiple transmitter, these three are efficient. And that's the difference between multiple inputs and single output and single input and multiple output. And the third case is our case, that is multiple input and multiple output. You can see both transmitter and receiver have multiple quantities. Yes, you have multiple transmitters with multiple receivers. So here what is improved is the channel robustness as well as the channel throughput. These two things is very important because throughput is most required. Throughput capacity and link reliability and link flexibility, link capacity. So these things are often referred, often asked while you're using a transmission between multiple transmitters and multiple receivers. Okay, so link reliability is very important, which is good in Mimo. So here you can find the general outline of Mimo system. So this is the general outline. Here you have uh, multiple transmitters and multiple receivers. Each transmitter occupies its own path to reach the receiver. So the wireless system using here is of space to time signal processing. Yes, it occupies the space, it requires the time to reach the receiver. So multiple spatially distributed antennas is used. Okay, so the two main formats are spatial diversity and spatial multiplexing. Yes, spatial diversity and spatial multiplexing. So spatial diversity is used in narrower sense. Okay, when you are using multiple transmitters and multiple receivers, of course there is a diversity in occupying the receiver path. It occupies diverse paths. So to provide an improvement in signal to noise ratio, they are characterized by improving the reliability of the system with respect to various forms of fading. Okay, so there are multiple signals transmitted from multiple transmitters. While they are occupying the multiple path, there are chances of fading. So overcome the fading, have to improve the reliability of the channeling capacity. That is improved by improving the spatial difference between the receiver paths, and that is what you call it as spatial diversity. Second one is spatial multiplexing. So to provide the data capacity, to increase the throughput, you have to multiplex. I mean different paths to carry the data so as to avoid the traffic congestion in the single path. This is spatial multiplexing. So these two things improve the performance of Mimo. The three things to remember in Mimo is the diversities in basis of time, frequency and space. This shows that Mimo is more advantageous. Of course, you require the time diversity. The signal may reach at different times. So you must have different time slots and channel coding. Frequencies mean it can use the signal can be of different frequencies that can be transmitted from transmitter to receiver. Okay, so it suppose the signals at different frequencies, different times and different spaces, that is space diversity. It is used in broadest sense that the definition is basis for Mimo. Okay, so of course it's not very easy to locate the different transmitters and different receivers in the same place. You require different places, so space diversity must be supported and it is the basis for Mimo. Of course the spatial multiplexing I have explained. Now this is advantage of Mimo. So what is the advantage of Mimo? So here by using multiple antennas wireless technology is able to increase the capacity of the given channel and the throughput of the channel is also increased linearly. So the overall advantage I like to say is there is no fading, there is no delay in reaching since we have time diversity, space diversities and frequency diversities and full utilization of channels and full reliability of channel link. Everything supports Mimo and thus it supports the latest wireless technologies. That's it. Thank you.